Hello and welcome back to Neo Psychology with me, your teacher, Mr. Neo, the channel where I teach psychology lessons to my wonderful students. Let's get started, shall we? Today we are carrying on with the module of research methods and we're looking at lesson 25, descriptive statistics. Let's have a look at that one. There we go, rock and roll, starter. You want to buy some headphones? So you have a look at reviews. Below are the two most popular with their ratings out of 10. So we've got two headphones here, AirPods and Sony. AirPods have a mean score out of 10 of 5.6, whereas Sony ones have a mean score of 5.5, so slightly lower. The range of the reviews is 9 from the AirPods, and the range of the reviews from Sony is 3. The standard deviation of the AirPods is 5.9 and the standard deviation of the Sony headphones is 2.3. Which set of headphones should you buy and why? You might not be able to answer that necessarily right away, but by the end of this lesson we're going to learn about these things and hopefully you will. What are our learning objectives for today? Today we're going to show comprehension and apply knowledge of measures of central tendency, which is mean, median and mode. This should be familiar to you from GCSE Maths. And learning objective 2, to identify and analyze measures of dispersion, range and standard deviation. Let's have a look. Let's get started. Learning objective 1. We have seen how data may come into two forms, qualitative and quantitative. Here we shall focus on the latter, so quantitative. There are various ways of summarizing and analyzing numerical data in order to draw meaningful conclusions. These are collectively known as descriptive statistics, which include measures of central tendency and measures of dispersion, and also graphs, which we're going to learn about next lesson. Let's start with measures of central tendency. Measures of central tendency are averages, which give us information about the most typical value in a set of data. There are 3 of these to consider: the mean, the median, and the mode. So there are 3 measures of central tendency: mean, median, and mode. Let's start with the mean. The mean is what most of us will recognize as the average. It is calculated by adding up all the scores or values in a data set and dividing this figure by the total number of scores there are. So you get the mean. If I was to find out what was the mean score in the last research methods test, I'd add up everybody's scores if there was, let's say, 25 of us, and then divide that by 25 to get the mean. For instance, in the following data set of scores, 5, 7, 7, 9, 10, 11, 12, 14, 15, and 17, the total is 107. You divide it by the number of scores. There are 10 numbers there, which gives us a mean value of 10.7. So the mean score from those data sets is 10.7. The mean is the most sensitive of the measures of central tendency, as it includes all of the scores or values and in the data set within the calculation. So this could be seen as a strength or a weakness. One strength is that, it includes all of the numbers in the data set, so that's a good thing. However, it could be a bad thing because it means that some numbers, some outliers, some numbers that are really big or really small might change the mean drastically. This means it is more representative of the data as a whole number. It uses all of the numbers, so it's quite representative of the whole thing. However, the mean is easily distorted by extreme values, like I said. If we replace 17 in the data above with the mean, with the number 98, the mean becomes 18.8, which does not really seem to represent the data overall, does it? So, how do you get the definition of the mean? They might ask you, what's the definition of the mean? Well, it's the arithmetic average calculated by adding up all the values in a set of data and then dividing by the numbers of values there are. Okay, the arithmetic average calculated by adding up all the values in a set of data and dividing by the number of values there are. The mean. Easy. We know the mean. Identify one thing you learned about the mean. Why is it important? How does it apply in real life? At A levels, we sometimes use your mean GCSE score. So we get all of your GCSE scores or grades, add them up and divide them by how many there are, and that gives you your mean. That gives you your mean GCSE score, and then sometimes teachers use that as a prediction for what you'll get in your A levels. That's a way in which we use the mean in real life. Median. Let's have a look at the median. The median is the middle value in a data set when scores are arranged from lowest to highest. Okay, so first of all, you need to remember, yeah, it's the middle value, but also you need to arrange them from lowest to highest. Okay, sometimes in the exam, if they gave you a set of data, they might give it to you from lowest to highest. Sometimes they might not, so therefore you need to make sure you write it out. Ensure that you have every single number there as well. So count how many numbers are there, and then you make sure you write them from smallest to highest, and then you've got the same number, so make sure you've accounted for all of the digits. In an odd number of scores, the median is easily identified. So if you've got an odd set of numbers, so if there was 11, there's going to be a middle value, which is quite easy. Okay. In an even number of scores, just as the 10 numbers before, so if we had 10 numbers, the median is halfway between the two middle scores. These are 10 and 11. So the median is 10.5. So you would get the fifth and the sixth number in the row, and then you'd add them together and divide them by 2, and then that will give you your median. And there are strengths and weaknesses for using the median as well. The strength of the median, unlike the mean, is that extreme scores do not affect it. So whether 98 replaces 17 in the number of 10 numbers we had at the beginning in the data before or not, the median remains the same. It is also easy to calculate once you have arranged the numbers in order. So 1 is easy to calculate. You just take the middle number, you put them from smallest to highest, and then you take the middle value. The other benefit is that extreme scores do not benefit. If I put a really big number at the top or a really small number at the bottom, with the mean, it will affect the mean quite drastically, potentially. But with the median, that's not the case. It will still be the middle value. However, it is less sensitive than the mean, as not all scores are included in the final calculation. Okay, and that might be a weakness. You haven't included all the data. So the median, how are we going to define the median now? It is the middle or the central value in a set of data when values are arranged from lowest to highest, smallest to biggest. There we go. The central value in the set of data when values are arranged from lowest to highest. The middle. You're stuck in the middle. And that's median. Identify one thing you learn about median. Why is it important? How does it apply in real life? Mode. Let's move on to mode. What is mode? The mode is the most frequently occurring score or value within a data set. In some data sets, there may be 2 modes or bimodal if no mode if all the scores are different. So the mode is the most occurring, the most frequent value. Okay, the way I remember it is go mode, M-O, most often. It's the number that appears most often. If there are no numbers that appear more than once, or all of the numbers appear the same amount of times, then you would say there's no mode. Although the mode is very easy to calculate, it is a very crude measure. Notice how in the set of scores before, the mode is 7, which is quite different from the mean and the median. So the set of scores we had before, the mode is 7, but that's not very representative, and it's not not really representative of as the whole data. So in this picture here, there are 5 birds. Which color bird would be the mode? It would be the blue bird, because the blue is the most occurring, the most often one there. For some data is categorized. The mode is the only method you can use. For example, if you asked your class to list their favorite dessert, the only way to identify the most typical or average value would be to select the modal group. Yeah, so if I said to everyone in class, what's your favorite dessert? Oh, I like cheesecake, I like pie, I like souffle. We can't do a mean of that, can we? It's not numbers, we can't take a mean. We can't do a median because you can't arrange them from smallest to biggest. Then we're not dealing with numbers, okay? With categories, you could do a mode though, which is the most occurring one. Most people liked cheesecake or whatever. And that's the mode. Mode, the most occurring one, okay? Easy, mode. How do we define it? The mode is the most frequently occurring value in a set of data. Right, let's have a look at a question now. We've got a table on the right. Let's have a look. The table shows the results of our energy drink experiment using a repeated measures design. Repeated measures. That means the participants took part in 2 different conditions. Okay, so I had in our energy drink, we were measuring how many words people say in a 5-minute period after they had drunk a drink. If it was independent design, independent groups would have 1 group in Red Bull, 1 group in water. In this example, we've got repeated measures design. So we got 1 group drinking Red Bull, and then afterwards we get them to drink water or vice versa. So each participant is experiencing both conditions, the Red Bull, the experimental condition, and the water, the control condition. The score for each participant is the number of words said in the 5 minutes after consuming each drink. Calculate the mean, the median, and mode for both the Red Bull and the water condition. Give all answers to the nearest whole number. So you should have 6 values there, okay? The mean for Red Bull, the median for Red Bull, and the mode for Red Bull, and then the mean for water, the median for water, and the mode for water. Okay? What's the mean? It's like the average. You add them all up and divide by how many are there. There are 10 participants. The median, put them in order from smallest to biggest, and then find the middle value. If there's 2 middle values, you add them together and take the average. And then the mode is the most occurring one. If there is no mode, then you say no mode. Give all answers to the nearest whole number, okay? So we're going to have to round up or round down for some of those answers. What can you conclude from these calculations? Okay, so once you've worked out those 6 figures, those 6 things, you can compare them to each other. What was the mean in the Red Bull? What was the mean in the water? What was the median? What was the mode? Do they compare? Do we think that one is affecting the other? Do we think that maybe Red Bull is affecting talkativeness or amount of words spoken? Maybe. Do the calculations and find out. Give yourself 5 minutes to work that one out. Give that a go. Otherwise, we are cracking on. Pause the video and do it now, please. Right, let's have a look. First of all, calculate the mean, median, and mode for both the Red Bull and water condition. So the mean for the Red Bull condition was 119 words in a 5-minute period. The median, so the middle value, was around 105 words. And the mode is there was no mode. With the water condition, the mean was 96 words. The median was 102 words. And the mode, again, there was no mode. Number 2, though, what can you conclude from these calculations? Well, there is a difference in the mean number of words spoken to around 23 words in the Red Bull condition compared to the water condition. We can conclude, therefore, that drinking an energy drink did make people chattier on average in the 5 minutes after consuming the drink. This would appear to support the directional hypothesis that was written at the beginning of the study. However, the difference in average words spoken is not huge, so a statistical test would need to work out whether the difference between the 2 conditions is significant. We are going to have a look at statistical testing in a bit. So the mean, median, and mode and measure of central tendency, you can have a look at 2 sets of data and see if there was a difference. And if there was some difference, you can go, yeah, there is a difference. But a statistical test finds out if the difference is significant, if it is actually meaningful. And that's the measures of central tendency. Identify one thing you learned about measure of central tendency. Why do you think it's important? How does it apply in real life? When do we use this? Do we use mean, median, and mode in the real world? Sometimes we do. Sometimes not so much. Any questions? You let me know. You got any questions? You let me know. And that's it. Learning objective 1 complete. We measure measurements of central tendency, mean, median, mode is being ticked off. Tick. And we're moving on to learning objective 2. Identify and analyze measures of dispersion, range, and standard deviation. Measures of dispersion. Measures of dispersion are based on the spread of scores, that is, how far scores vary and differ from one another. We shall focus on two of these, the range and the standard deviation. How spread are the scores? Are they quite close to the mean and there's a really small set of data, or are all the pieces of data really far away from the mean, so they're really spread out? And that's what we're looking at, a measure of dispersion. There are two measures of dispersion we're going to learn about, range and standard deviation. The range is a simple calculation of the spread of scores and is worked out by taking the lowest value from the highest value and usually adding 1. So what's the biggest value? What's your smallest value? Biggest minus the smallest, and then add 1. Okay, easy. That's a really easy way of understanding the range. Thus, the range for the data before is going to be the biggest value, which is 17, taking away the smallest value, which is 5, and then adding 1, which gives you the range of 13. Some of you may or may not be familiar with adding 1. The reason for this is that adding 1 is a mathematical correction that allows for the fact that raw data scores are often rounded up or down when they are recorded within the research. The number of 1 accounts for this margin of error. If you don't understand that, don't worry. It's biggest minus smallest, add 1. Okay, easy. The advantage of the range is that it's easy to calculate, really easy. Biggest minus smallest, add 1. However, it only takes into account the two most extreme values, and this may be unrepresentative of the data set as a whole. For instance, pupils in a maths class achieve the following test scores. We got 0, we got 47, I'm guessing these are percentages, 47%, 49, 50, 50, 51, 53, 54, 56, 56, 57, and 100%. Here, the range here is 100, because you do 100 minus the smallest, which is 0, plus 1, 101. Okay, that's not very representative. The range here is 101. One student was ill during the test and scored nothing. The top scoring students had been given the paper for homework by mistake. So we've got one person did the test as a homework and got 100%. We've got one person didn't turn up and got 0, and therefore it's not very representative. This illustrates the problem with the range, that it may not give a fair representation of the general spread of scores, as in this example, most students achieved around half marks in the test, and the range, more accurately, was 11 if we take away those outliers, we take away those really big and small scores. So it's easy to calculate, but it might be unrepresentative. Range. So the range is a simple calculation of the what? Dispersion in a set of scores, which is worked out by subtracting the lowest score from the highest score and adding 1 as a mathematical correction. And that's the range. Are we happy with the range? If you've got any questions, let me know. Range it up. Standard deviation. SD. A much more sophisticated measure of dispersion is the standard deviation. This is a single value that tells us how far scores deviate or move away from the mean. And that's how you calculate it on the right. Luckily for you, you don't need to calculate the standard deviation. You need to calculate the mean, median, mode, and range, but you do not need to calculate the standard deviation. The larger the standard deviation, the greater the dispersion or spread within a set of data. If we are talking about a particular condition within an experiment, a large standard deviation suggests that not all participants were affected by the IV in the same way, because the data are quite widely spread. It may be that there are a few anomalous results or like errors. So the standard deviation, if I put it into words, is essentially you get a set of data. So say there's 10 numbers, you find out the mean, and then you work out what's the difference between the mean and value 1, and the mean and value 2, and the mean and value 3, 4, 5, 6, 7, 8, 9, and 10. Okay? So I've got the difference between the mean value and all the other 10 sets of data, and then I take an average of that, and we can see, how far away are the majority of the results from the mean? If there's a really high standard deviation, it means, there was people that were a really high range of results. Some people were really above the mean, and some people were really below the mean. If there's a low standard deviation, it means, all of the results were around here. They were, and the mean was here, and there was a small standard deviation. Some of them a little bit higher, some of them a little bit smaller. But you can see the deviation is quite small, or the deviation is quite big, the dispersion. Okay? So a small standard deviation, a small dispersion, a large standard deviation, a large dispersion. And an example they gave, if you asked to give someone medication, you go, how much better did they feel? And you go, if you have a large standard deviation, it helped people drastically in some cases, but it didn't help people a lot in other cases. If you have a really small standard deviation, it goes, it had quite a similar effect either way. A low standard deviation value reflects the fact that the data are tightly clustered around the mean, which might imply that all participants responded in a familiar or similar way. The standard deviation is a much more precise measure of dispersion than the range because it includes all values within the final calculation, okay? Because it includes every value and it calculates the difference between each value to the mean, it includes all values, so that's good, it's more precise. However, for this reason, like the mean, it can be distorted by extreme values. If I had all the values in like a really small standard deviation, but we had one value that's all the way down here, a massive ridiculous value, that would affect it, go, the average between all of them was, the standard deviation was this amount, and it might not be very representative. So, standard deviation. It's a sophisticated measure of dispersion in a set of scores. It tells us how much scores differ or deviate from the mean by calculating the difference between the mean and each score. The way I usually explain this, if some people don't understand, is, for example, if I went into Boots and I wanted to buy some makeup or any other beauty products, right? I might go, right, I'm going to buy some lipstick, that's a £5. I'm going to buy some foundation, that's £7. I'm going to buy some mascara, that's £6. And I'm going to buy some face cream, that's a £5. Okay? All of those things, if I took the mean value and I found the standard deviation, I have a really small standard deviation because, look, it's got a really small standard deviation. They're all quite similar to the mean. If I went into somewhere like TK Maxx, for example, I'll go, look, they've got some lipstick here that's like £2, but they've got this really expensive foundation that's like £27. I don't know how much foundation it is. Or they got this mascara here for like £300 or whatever. And I got this like nail varnish for like 50p. Right, that would be a really large dispersion of results, okay? There'll be a really large difference. So some of them will be really large dispersion, a really large standard deviation compared to the mean, okay? So you go, this has got a large standard deviation. The one from Boots has got a really small standard deviation because they're quite similar. And that's standard deviation for you. Right, now we're going to use all of that data to try and answer this question. The table includes a summary of the results gained from an experiment. The experiment compared the number of words recalled when words were learned in silence compared to when words were learned whilst music was playing in the background. Okay, so we're trying to learn words. I'm going to give you a list of words. I'm going to see how many words I can remember. In some of them, they learn these words in silence. In another group, they learn them with music. So let's have a look at the table. Number of words recalled. So we got the mean and the standard deviation. And we've got condition A, which is learning them in silence, and condition B, which is learning them with music in the background. So we can see the mean number of words remembered in silence was 21.2. And the mean number of words learnt in condition B, which is the music condition with music in the background, was 14.6. The standard deviation for condition A, silence is quite small, it's 1.1, whereas the standard deviation for the music is 4.6, so slightly higher. What conclusions can be drawn from the mean values above? And then what do the standard deviations tell us about the scores in each condition? Now, in an example like this, it's not good enough just to say, well, the mean was 21.2 and the for condition A, silence, and the mean for music was 14.6, right? That's fine. That might get you a mark or two, to be fair. But explain what that means. Put it into actual words, right? Talk to me like I'm talking to you, not at the pub. You shouldn't be going to the pub. You're too young. But like, if I was talking to you as a friend, go tell me, explain these results to me. You go, well, what it means is this. Right, pause the video. Give yourself 5 minutes. Give that a go. What does the mean show us? What does the standard deviation show us? Right. Number 1. What conclusions can be drawn from the mean values above? The higher mean number of words recalled in condition A, 21.2, compared to 4.6 in condition B, would seem to suggest, from these participants at least, that learning words in silence leads to higher recall than learning words of background music. It was 14.6 that's meant to be. So the higher mean number of words recalled in condition A, 21.2, compared to 14.6 in condition B, would seem to suggest that for these participants at least, learning words in silence leads to higher recall than learning words with background music. You could add, it may be that the music acts as a distraction which prevents the words from being processed as effectively. Okay, you can make some assumptions based on that. What does the standard deviation tell us about the scores in each condition? The highest standard deviation in condition B of 4.6 compared to condition A, 1.1, shows that there was more dispersion of scores in condition B. In condition A, scores were more clustered around the mean. This means that there were more anomalous results in condition B, suggesting that not everyone is equally affected by the background music. Yeah, so what this shows us is the fact that there was a higher standard deviation in the music condition. It showed that some people, they found it quite helpful to have music to remember. However, other people did find it distracting and didn't find it helpful in terms of memorying. Whereas in condition A, where it was just silence, it was a very small standard deviation, meaning that everyone was sort of affected in a similar way. And they are the measures of dispersion. Identify one thing you learned about measures of dispersion. Why do you think learning about this is important, and how does it apply in real life? Again, if you've got any questions, let me know. And that's learning objective 2. Identify and analyze measures of dispersion, range, and standard deviation. Okay, let's move on to the plenary. Multiple choice again. I think I've got 4 of them. Number 1. Which is not a measure of central tendency? A, range. B, median. B, mean. C, median. Or D, mode. Which is not a measure of central tendency? Did you say B, mean? Well, you're wrong. It's A, range. Good. Number 2. Which would be the most appropriate measure of central tendency for the following data set? 34, 36, 36, 37, 38, 39, 39, or 673. Which would be the most appropriate measure of central tendency? A, the mean. B, the median. C, the mode. Or D, none of them? Well, it's not the mean, because the mean takes into account all of the values, and because there's a really big outlier value there of 673, that would affect the mean quite drastically. So I think it would be most, and with the mode, it looks like there's 2 modes, so it's not really the appropriate. So I would say the median is the most appropriate. B, the median. Number 3, a high standard deviation might indicate what? A high mean, a low dispersion, a widely spread set of data, or a repeated measures design? A high standard deviation. It's widely spread set of data, C. And number 4, adding 1 as part of the calculation of the range is A. What? A. Standard error. B. Normal distribution. C. Way of balancing extreme scores. Or D. Mathematical correction. It's mathematical correction. There we go. How did you do? There's a link to a video if you had any difficulties with any of that. Otherwise, thank you for today's lesson. That was lesson 25, graphs. Well done, my neo-psychologist. You've been brilliant. God bless and peace.
I'm feeling like Will. I feel like a prince. I'm feeling myself. I'm loaded with bills, cause I wasn't blessed with no Uncle Phil. Don't know how it feels. I wanted to flex, they told me to chill. I'm making a flip. My life is a flick, now load up the film.